A lot of people have trouble forge welding. I've heard many stories over the years, and I do not have any difficulty using steel in a coal fire and actually forge welding it, flux or without. And I started to look at the design of some of these forges, and it seems like there's three prevalent designs. There's the sloping pot, goes right to the tweer. There's a European style that has two shoulders on both sides, and I haven't actually tried one of those or had the opportunity to actually examine one up close, because all I've ever seen is on a film or videos. And then there's the type that I know a lot of you have seen that has a donut around the tweer. And the three different types seems to be work differently. The main problem with forge welding is dirt or a dirty fire. If you have a buildup of clinker, which I know most everybody has had that occasion to have many clinkers, as soon as you have a clinker, the clinker absorbs a lot of the heat by removing a commodity that can actually burn to a commodity that doesn't burn. So it's a heat absorber instead of a heat giver. The air comes up through it, it absorbs the heat, and it's difficult to get a very hot fire out of it. That's really probably not the main problem. The main problem is the impurities that exist in the clinker. As it's being heated, those impurities form a sort of a gas that is contaminating the source of heat. It's almost as if you threw a penny in somebody's forged fire that they were forge welding in. You will not weld anything in that fire the rest of the day. And because you're going to get copper oxide forming on the metal that you're trying to forge weld, and you cannot get rid of it. This is about the same situation. That oxide from those clinkers are going to be attracted by the metal that's in the fire that you're trying to weld. And flux will help that situation, but many times you'll be unsuccessful just because of the clinker. So that leads you on to looking at, well, how do you get rid of the clinker? If you have a sloping forge pot like this that goes right to the clinker breaker, and you have a clinker breaker, then you can extract those periodically out of the forge. If you have a donut around the bottom, it traps the clinker somewhat on the outside, and it will eventually cover over the air supply if you leave it go long enough. I've not had good luck with that style. I've had better luck with the sloping right to the clinker breaker and getting rid of the clinkers periodically. That seems to work better for me than anything else. And I don't know about the European style of shouldered forge, but that's the main differences, is that the design of the pot and a way that you can get rid of it and put the clinker someplace else out of the air supply. So that's pretty much my knowledge of what is actually happening. You'd like to have if you're going to forge weld, you'd like to have a big fire with a met coke. But a lot of people don't have met coke. I had a friend that, Hugh Bartruck, that had a supply at the Alverton Coke Works, and for years he would go there and he welded every day and never had a problem because he used met grade coke. It was already made into coke for him, small sizes, and I had some association with realizing that met coke really is a great thing for making knives. So if you're going to make knives, then you might want to consider making coke first before you even start.